This is a piece of high density MDF that came out of a treadmill. It's pretty thick stuff and it should allow you to build something that's capable of high RPMs, and the scale was small enough that it will make it cheaper to produce. What we're going to do here is we're going to cut this part off because it's going to be square, so this is going to be cut off. And what it is the board is 44 3/8. So 44 3/8 is 22 3/16. Use that, and we're going to line this up. Because this board has already been squared, pretty easy to use the sides and work this out properly. There we go. So we're going to mark this. Okay, now what we're going to do is find the center of half of this board by going diagonally from corner to corner, from the corner of the board to the mark that we just made down the center in both directions. Now you don't need to mark it the whole length of the board, you only need to mark it in the center, and that creates the exact center of half of this board, which represents one side of the motor. Now I'm going to index the center with this bit. You can do it with a drill bit, but this is just a little more accurate. We're going to index this point here. This is critical you get this right. So because we are using components from an exercise machine, this shaft right here, which is out of like a Nordic Track type machine, has the bearings, the spacers, everything you need. If you can't find a Nordic Track machine or an exercise machine with the parts you need, you can go to the hardware store. You can buy a piece of stock to do the same thing in the bearings. Now that's going to cost you a lot more. If you go to a thrift store, you might pick up an exercise machine that's been sitting around. You might be able to pick one up for $4 or $5 even. There's about $20, at least $20 worth of metal parts that you need, including the bearings and the spacers in there. So check around, see if you can find one first. It's going to be your cheapest route. I'm going to use this shorter piece I have to index so it's not sticking up that far out of the piece of wood while we are doing this video. So you know, this is the actual shaft. This is what I'll use to do all my measurements, so it's a little easier to comprehend what you're looking at. And this is a single-sided wheel that in the exercise machine, it's a ski machine, and it's got a one-way bearing in it. And I found a lot of uses for these. It's a handy thing. Not to mention, I have to drill this hole. So I can lay this down flat, and because you can't get this under a drill press, it's too big. If you can get it out of this drill press, then I'm wasting my time because you got a machine shop. You check which direction. Now you could do this with another plate. You could drill a plate, a thick piece of metal, and make sure your drill press is perfectly perpendicular, and drill a hole the size of your shaft, because what you're going to do is use this to ensure that you're going to go straight through this board. And this is critical. If it's even off a 1/16 of an inch, you're going to have a hard time getting that wheel to run true. So this is a way to do that and to do it more cost effective. So I'm going to put this in here like this, sit that right in that spot I indexed. Okay, we've got the boards cut the end off of the board, and then I pin these boards together. So everything I do to one board is going to be done to the other board. Basically, they're locked together, and they represent both sides of the motor. The wheel's going to be cut out of the middle, but the sides need to be perfectly aligned. And we're just going to go ahead and hammer this shaft in this hole. That'll give us the point to swivel. What this is it's 9 3/4 inches from the center of that hole. Now the box motor can be adjusted up or down according to what size you're working with and how big your coils are. You can make it literally any size you want, and you drill a hole at the size of the wheel, put this pencil in here, and just go around this wheel. Real simple. There it is. That's the diameter of the wheel. This is the motor alignment guide that we put out last year. And this will be included in the PDF and on the DVD. I used an X-Acto knife to cut the center out of this right here. As you can see, you're just going real lightly around the outside in that dark line. These are standard motor shaft sizes. You determine the size of the shaft. In this case, this shaft is that second one right there. So you're going around it and you cut the hole out. Now once you've done that, we're ready to start marking where the magnets are going to be and where the coils are going to be. So this fits over that like that. Right now we're going to mark positions for the wheel, for all the magnets on the wheel. You gotta be real careful. These blades, these small drill bits are easy to break. Now you could hammer them in. I've done that in the past, but tapping them a little bit gives me a better fit, and I'm sure to get it in the right spot. So what you're going to do is you're going to mark the red ones now. We're going to mark where the magnets are. So what you have to do is you have to drill and that's our first mark. Now what you do with this, you have a good straight edge. You're laying the straight edge up against the pins. Now when you do that, that leaves a little space. So when you mark this, you're marking exactly on that line out here. We're going to go to this point and we're going to mark this. Now this represents a magnet point. So we're only marking that there. Now we got the first two marks set up, so this is stabilized. And what I did here is I went along and I drilled every place there was a magnet. So I've got the pins in. I'm going to set the marks everywhere I need a mark around this wheel, and that'll establish the line for the magnet and the line for the coil. The coil position and the magnet positions will all be done at this time. Now we've marked the wheel, and what I did is I created these bearing blocks here. Now you could buy something similar to this. It's called a pillow block. Instead I just made it out of plastic. Simple. Put a couple bolts through it. So by sliding them on in opposite direction like that, this one will actually be on the other side of this piece of material. So I want them to line up, so I flipped it over and put it on top. So when I create the mounting points on the motor, the alignment will be correct. I use plastic for this. It's simple, easy to do if you have a resource for plastic. This is just aluminum square tubing. I bought surplus. This could be made out of any material, wood, depending on the weight of your wheel, and you can buy off-the-shelf parts to do this or use recycled materials here in this case. Once I've got these bolts in here, I'm going to drill, and the best way to do that is to use a square, and by pushing this up against the edge, that ensures that's straight across. And then I just used a drill and mark the material. The one on this side will be straight. Now I have to do the same thing on the opposite side to ensure the whole thing is completely straight. Needed to finish these components so the coils never ended up anywhere near the mounting points, so they had to be created first. Now I positioned this on where it lines up with this line. That's not really necessary, but to simplify this, I thought it'd probably be best. Now what we're going to do is find the positions out here that we want the coils to be mounted, and what's crucial about this is the most amount of drive torque into the wheel, which means they're spaced out evenly. That creates evenly spaced 3-point firing position for the coils. First we're going to set up the first coil, and I'm going to put the coils next to each other as close as possible just to make it easier to wire this up later on. This will actually interfere with the positioning of the coils, so with this sitting here, it'll be the same on both sides. I should be able to use the one side to figure out mounting points for the coil. In this spacing, it was 4 or 5 spaces apart in order to get it lined up like this. So each one of these patterns is repeated, and the trick is to set it up in a way that it doesn't interfere with any of the structure but still allows the coils to be positioned in the optimal position. Basically how it has to be configured in order to get this sequential firing happening. Now the trick about this is not to take off too much material and to go slow and make sure you get a good cut. And if you feel your router starting to heat up, let it cool down for a while before you finish your cut. I routed one pass on this, and I wanted to show you this tool here. Before I go any further here, I want to show you, this is the universal tool for the box motor. This line, the router mounts here. This is the center line. Allows you to line up your index lines with the center. And this is the mounting point for the coils around the wheel. So we have a center line, and I drilled these, and this will be used to drill the holes in the frame and also in the bottom of the coils. Slide these under and drill these holes. That way everything will line up perfectly. Those positions, as you can see here, I hold that down and I just drill these 2 points, and that's the anchor point, and that'll drill through both pieces, and that'll give me the anchor point on both sides of this frame for the coils. Alright, we got all 4 pieces cut out, and if you can see, this is rough, but that's okay because when we mount it, I can run along the edge and smooth the edge up. Of course, the edge don't really matter, it's the magnetic field that's generated by the magnets on the edge. Both pieces on both sides are cut, and I'm going to clean this mess up and I'll be right back.